Alright, this is 4-2, Algebra 2, standard form of a quadratic. So last time we talked about vertex form of a quadratic, and vertex form is in the order of f of x equals a times x minus h squared plus k, where the vertex is hk and the axis of symmetry is h. Okay. In standard form, which is what we're going to talk about today, it's in the form of f of x equals ax squared plus bx plus c. Standard form. The vertex it's going to be in the form of negative b over 2a f of negative b over 2a, and the axis of symmetry is going to be negative b over 2a. That's going to be our theme for today. Negative b over 2a is going to be said a lot today. All right, so that's standard form. I'm not going to ask you to graph. I mean, you'll use decimals to graph, but here is what I just said. Oh, the one thing I forgot to say is the y-intercept. So ax squared plus bx plus c. The y-intercept is going to be equal to it's y when x is 0, so it's going to be 0 c. Y-intercept is going to be 0 c. Alright, here's the proof for negative b over 2a, and we start off in vertex form. F of x is equal to a times x minus h squared plus k. So we have this x minus h squared. We're going to actually square that. So that's step 1, square. So x minus h times x minus h, and do that process. So that's going to be x squared minus negative xh minus negative xh plus h squared, which turns into x squared minus 2xh plus h squared, negative 8 to 2ab plus b squared, a squared plus minus 2ab plus b squared. That's the first step. Second step, we're going to distribute that across to a. So instead of calling it x minus a, it's going to be a times x squared minus 2xh plus h squared plus k. So we're going to distribute that a across. And that's going to give us ax squared minus 2a hx plus ah squared plus k. Okay, so let's look at that second part here. The negative 2ah. Alright, and we're going to make a comparison to standard form, which is ax squared plus bx plus c, right? So this pertains to the c, this pertains to the b, and then a is the same. So what we can say is, for step 3, is that if we're solving in terms of what b is, we can say that b is equal to negative 2ah. B is equal to negative 2ah. Well, if we look at our standard form, we have two of those letters already. We have B and we have A. So we can solve this in terms of A and B, and we can say that we're going to divide negative 2a from both sides. And we're going to say that h is equal to negative 2a, negative b over 2a. So that's where negative b over 2a comes from. Remember that h is the axis of symmetry, right? Our vertex is always going to be hk, and h is our axis of symmetry, so then we can say that our vertex is going to be negative b over 2a, f of negative b over 2a. That's our hk. So that is where negative b over 2a comes from. In terms of using it to graph, here they have this graph right here, y equals x squared plus 2x plus 3. And everything's going to revolve around the axis of symmetry and the vertex. Notice that if there's no number in front of here, we know that there's a 1. So a is going to equal 1. B is going to equal 2. And then C is going to equal 3. So axis of symmetry, step 1. Axis of symmetry is negative b over 2a. So we're going to substitute all of that in. Negative 2 over 2 times 1. And that gives me an axis of symmetry of negative 1. Then we could find the vertex, and the vertex is going to be f of negative b over 2a. In this case, it's going to be f of negative 1. So we're going to plug in negative 1 for x here, which is going to be negative 1 squared plus 2 times negative 1 plus 3. 1 squared is 1. Take away 2 plus 3. So that's going to be negative 1 plus 3, which equals 2. So my vertex is negative 1, 2. So that's my axis of symmetry. I got my vertex. So I can use those to set up my graph. And the next thing that we can do is we could find the other point reflected across the point on the C, or the y-intercept. So the y-intercept is 0 when, or y when x is 0. So if I plug in 0 for here, I'm going to get 3. So then the ordered pair is going to be 0, 3. That is my y-intercept. Take a look at this. I have my axis of symmetry, and I have my y-intercept. So if my axis of symmetry is at x equals -1, and my y-intercept is at 0, or x is 0 at the y-intercept, I can count the distance from the axis of symmetry to the y-intercept. So the graph is going to sort of look like this. It's going to be an upward facing graph at the vertex, right? This is -1, so it's going to go this way. Here's the y-intercept at 0, 3. Since this is a reflection, the distance between -1 and 0 is 1 in the right direction. So if I go a distance of 1 in the other direction, and this is -1, and if I go another distance of 1, then this guy is going to be -2 and 3. -2 and 3. So I have 2 points that I can use as a reference. -1 is in the middle, 0 is to the right, -2 is to the left, and they both have a distance of a reflection of the same from the axis of symmetry. So I can have those 3 points right there, and then that's the vertex. And that's enough information for me. I need 3 points at least to graph this. And then since I know A is positive, it's going to be in an upward facing direction. So my vertex would be -1, 2. The y-intercept would be 0, 3. And then the reflection across the reflection across the vertex is going to be -2, 3. I use those 3 points. I know it's going to be facing upward. A is positive. So it's going to be concave up. And that's enough information to graph. And it's going to look like that. Like the picture. Here's the vertex. Here's the y-intercept. Here's a reflection across that. So since this is 0 to -1, has a distance of 1, I go another distance of 1 from -1 to the left by 1. That gives me -2. So that's the -2, 3. That's the 0, 3. And this right here is the -1, 2. And that's enough information, 3 points, to graph that guy. Or you can also graph it from the vertex using the XY. Another option. You can do FY, and you can start from the vertex as the middle. So since the vertex is -1, you can go like -3, -2, and then 0, 1, 2 from the vertex, knowing that the vertex is in the middle. And you can go 2 down from the vertex and 2 up from the vertex. That's an option too. A lot of people do that. And then you could plug in your x accordingly. This is 2. So that's another option that you can do as well, if you want to graph it that way. All right. I won't do got it number 2. Converting into vertex form from standard form. Okay, everything revolves around negative b over 2a. We put in the vertex, and that gives us our h, and then we have to do f of the vertex, and then get our k, and then we can put it into vertex form. So in the case of got it 3, we have f of x equals negative x squared plus 4x minus 5. Remember that the vertex h equals negative b over 2a. Here we have, this is negative 1a, so it's going to be negative 4 over 2 times negative 1, which is positive 2. So then we're going to plug in f of 2 to find what k is. So k equals f of negative b over 2a, which is f of 2, which is negative 2 squared plus 4 times 2 plus 5, which equals negative 4 plus 8 plus 5. Negative is minus 5. Yeah, I was doing something wrong. So that's 4 minus 5, so that's negative 1. So k equals negative 1. So my vertex hk is 2, negative 1. Now that I have my hk, I can convert it into a vertex form. Remember that vertex form is f of x is equal to a times x minus h plus k. Here's my h, here's my k. So I can, and my a, in this case a is also negative 1. So I can say that f of x is equal to negative h minus 2 minus 1. That would be vertex form. Everything stems from negative b over 2a, the vertex. Here, we have this bridge in China, which is the oldest known arc bridge. They want to find what x and y are measured in feet of the arch, I guess. Let's see. Oh, where x and y are measured in feet. So they want to know how high the arch is. Okay, so we have to find the vertex. So here's our equation. F of x equals negative 0.0001075 x squared plus 0.13131148 x. Notice that there's no plus c, so that means that this guy is going to start from the origin. In order to find the height of the arc, I have to, since it's a downward concave down facing parabola, it's going to look like this. So I need to find the maximum, which is the same thing as the axis of symmetry. And then so that would be my x. or my h, if you want to think of it as your h. The y is going to be your k, which is what they want us to find. So let's do that. Everything starts from negative b over 2a. Here, a is equal to negative 0.001075, and b is equal to 0.131148. So when I do the axis of symmetry, which is negative b over 2a, I'm going to plug in negative 0.131148 over 2 times negative 0.001075. That's going to give me some number, which is approximately 61 feet. Approximately 61 feet. Okay, so we're going to plug in that to find our height. So that's going to be f of negative b over 2a, which is f of 61. That's going to equal our k, or our height above the arc. So that's going to be negative 0.001075 times 61 squared plus 0.131148 times 61. Okay. Squared negative. I get about 4. So the height of the arc is about 4 feet. Okay. They ask, why does the model part not have a constant term? Meaning, why is there no plus c? That's because c in this case is 0, and if it's 0, then our y-intercept is going to be 0, 0. That's our y-intercept. When there is no c, that means that the parabola is going through the origin. Alright, that's our section. Hope you have a great rest of your day.